Okay, wonderful. All right, well, I'm George Flanagan, and I'm just about to welcome another set of new users to the summer research program here. And over the years, I've noticed that most of the people who are truly new to summer research on Linux and the HPC environment come from Macintosh and PC. And that presents some problems because of just the unfamiliarity of the Linux file system. So this very quick talk is not so much to introduce you to how to use a bunch of different commands as get you familiar with the way things are put together in Linux. It can seem a little odd. The file system is best thought of as a tree with leaves, where the leaves are your files and the branches of the tree are kind of how they're organized and how one file is related to another one. The first thing you have to do in Linux is get rid of a few things that you may have learned on Mac and PC, and that is that disk names and drive letters don't really exist in Linux. The Linux file system could be huge, span petabytes, and obviously there's no such thing as a disk drive that's that big yet. So it's a different kind of organization. This tree that we talk about is paradoxically usually drawn upside down. And that doesn't always create a problem. We can kind of rotate it in our minds, but that's the way you will usually see it. And I'll show you that in a diagram that is coming up on the next slide. You have a good bit of freedom about how to organize your own files. And that's a good thing, but it can also be a pitfall. I remember when I first started using an early version of Windows, I had a desktop that was just completely filled with icons, and I couldn't find anything. So a good deal of care must be taken, pardon me, because there are often so many files. Now, one little thing that's true, though, is there's no easy way to do this. It's much like driving in freeway traffic. There's no simulation for it that is good enough that you would really learn to drive on the freeway without bringing your car out and taking a chance and trying not to run into people. So it's just it's an unavoidable complexity. Well, there are a few standards about how files are organized in Linux, and it is referred to as the File System Hierarchy Standard. And there are a million of these diagrams on the net. I picked this one. I'm not exactly sure why. It could have been that it was easy to download the image. But if you get the idea of the tree here. At the very top level, there is this slash. Notice it's a forward slash. It's not a backslash like it is in Windows. And it is the root directory that is construed to contain everything in the file system. All of these little things that are drawn as folders are more typically called directories in Linux. Every system has its own vocabulary, and directory is kind of the preferred term. If you use folder too much, people will start to look at you and say, you must still have your head on your Macintosh or your PC instead of here in Linux where it belongs. The way that directories get their name, and people like me tend to say them, is the directory name is said without the slashes in there. So this directory that's name is slash user slash local will usually just be called user local. So we'll ask where some file is, and they'll say, oh, it's in user bin or user local or something. Many of these directories that are on here are part of the standard, and you can get an idea that there's a good bit that's pre-installed on Linux. It's not quite like at least the Macintosh, where you have an applications folder that is this place where almost everything is. It's a little bit more diverse here. Well, what about your own files? Well, one of the things to keep in mind is that there's a context that's always present that you are quote unquote in some directory. And people will ask you, well, what directory are you in? And what they're asking is, what is the current context of whatever it is you're trying to do? All the files, all the directories have owners. And if you create the file, it is owned by you. This concept of ownership can be a little bit strange, especially on a HPC environment where there may be hundreds or even thousands of users, which means there are probably hundreds and thousands of owners because everything on the system is owned by somebody. You have a home directory. You can always refer to it with this symbol, the dollar sign and the word home in all capital letters, and that's generally pronounced dollar home. This can be important because you're often talking to somebody on Zoom or over the phone or whatever, and they say dollar home, and you wouldn't want to look for something that's spelled DOLLAR. All right, you can put thousands of files in the same directory, but you should not do that. You should group them. Now I suggest that you look for a tutorial on the simple Linux commands, but there are two of them that give you a sense of this structure of making directories and being in one. There's one called mkdir that makes a directory within the current one. Remember, you're always in some directory. I think that's pretty similar to, I think there's a Windows command or something that's md to make a directory. This is the same sort of thing. Then there is cd to change the directory. And so that goes from wherever you were, your current context, to a new one. And that's pretty much how you make your structure and move around in it. Well, what about a short example here? What does this tree really look like? Well, it looks something like this, and there's a program that you can probably persuade your system administrator to install if it's not already there, called Tree. Ah, catchy name, huh? And it will draw these diagrams on the screen so that you can kind of see the relationship here. As this presentation goes to the right, we see directories that are contained within other directories. Finally ending, probably these are files here at the end. I just picked something that had a lot of indentation in it because I wanted to stress that it could be drawn this way. Now, let's take one quick look at the program that allows you to inspect a file or a directory and give you the information about it. This little program is called LS, and there are many variations on LS, and it has a lot of what are called options. This little dash lowercase l that follows LS is what's called a dash option, a command line option, or just an option. Unfortunately, a lot of ambiguous names there. So that ls-l gives you the details about the file. In this case, the file name is hpl.dat. I have no idea what that file is. I just randomly selected it. One of the key points, though, is that the name is case sensitive. In fact, in Linux, everything is case sensitive, at least everything I know of. Case, upper lower case, is a relationship that really doesn't exist. The second line is the one that gives you the detailed information about this file. We'll not talk about permissions right now, but these are the permissions that are on the file. This little gibberish at the front, there's read, write, there's an X for execute. There are a bunch of other letters that you may see from time to time. And as you get into Linux, you'll learn about them. Now, Zeus here is the owner of this file. Uh, that first column there after the permission, or so I guess it's really the second column, uh, tells who owns the file. And as I mentioned, every file, everything on the system, it has an owner. Then there's local user. This is a group, and it tells you something about the which group of users owns or has permissions to the file. Everything's kind of has a group association as well as an owner. And as you get farther into it, that will make more sense. 1456 is the number of bytes in this file. A lot of times, depending on the formatting, you'll see this contracted so that it will just it'll show 2M or something for 2 MB. So, but as it without any modifiers on it, it's strictly the number of bytes. Finally, we have this thing that tells us the last time this file was modified. As the files get older and older, and I think we have some files on our system that are back to 2008 or something, that's pretty much all that will show there because it strips off some of the details. Okay, what is the complete name of a file? And so I wanted to just jump into a directory here and look around at just one file and let you know that there is this command that you can issue called real path. And you give it a file name and it will tell you the complete path name of the file. This is important because a lot of times when you're solving problems, this is a fact that the person helping you will want to know. I'll conclude with just a couple of quick suggestions about handling your files. The first one may seem a little bit obvious, but it is give files and directories, I spell that there, a meaningful name to you. It doesn't need to be, if I'm helping you, it doesn't need to be meaningful to me, but it does need to be kind of distinct. So script1.sh is one that I see a lot, and then I'll see script2 and script3, and it becomes pretty confusing because every directory seems to have one of these files in it, and I can't find my way around in your stuff. Next up, uh, do not use.
You have a board you need to put up in there?
I'm on the telephone. Can I talk to you? Okay. Uh, do not use spaces in the file names. If you are coming from a Windows or Macintosh environment, that's quite likely the case that you have used them in the past. They don't work very well in Linux. So join things together with dashes and dots and underscores. You can have as many dots as you want. File names can be quite long. And create a directory for each project. Try not to blend them together, even if they share some common data files. There are ways around this. And then in that one directory, put all of your files together. And I'm going to relinquish the sharing here. And that is something I may not, let's see. How do I undo this? I seem to have become the person hosting this.
I think Eric could take away George's.
Okay.
Is that true, Eric?
I'm looking. I'm going to uh
Yeah. Okay. You did it. Thank you.
I didn't do it.
I was trapped.
I think Luciano did it.
Thank you,
Yes,
George.
I think I'm the second one, right? I'm the second one, so I just I cut it.
That's good.
Yeah. So, do we have anything in between, or should I just start? Eric, you're muted. What?
Unless somebody has a quick question in between, I thought that maybe there would be questions at the end.
Okay. Okay. So I'll start. I I'll go very quickly with the kind of terminology, and then I'll go directly into the kind of my demo. Today I'm going to talk about the Linux command line interface, which is in short CLI. It is different from the graphical user interfaces like usually which we talk about we call it GUI. This is the thing I'm using now. It is a GUI. And there are several terminologies like what is command line, what is shell, what is terminal, and what is prompt. But I feel that's not important. It's something if you're confused, you can look at it. But I'll just jump into the how to use a shell. So shell comes in different flavors like TCSH, Bash, ZSH, like that. But today, because I'm using the George Mason's Hopper cluster, which is based on Bash. So on the second slide, I have some useful commands here. I'm not sure whether we're going to share the slides or not, but feel free to take a screenshot if you want. But I'll directly go to the demo. So first, if you're a Mac user, you probably know how to open the terminal. And if you are an Windows user, you can type something like cmd, and then you will find out your command line prompt here. But I'm using an alternative one because I like the white background. But anyway, so let's start with SSH. So to get into your system, the command line is SSH, which is the secure shell environment, allows you to remotely securely access your server. And it comes with a username at your server domain. In George Mason case, it is the cluster name Hopper .org is the Office of Research and Computing .gmu.edu. I think William Mary has a similar format with probably coming with cyclone something. cyclone.wm.edu. Probably. I don't know. Eric knows that better. So you hit the enter. It will ask you to enter the password. Once you hit the enter, a common error here is that it hangs here. Nothing will happen right now. It's because of the new security feature added by George Mason side to wait for the dual two-factor authentication. It's something on your phone. So you have a duo app. You have to hit the approve. So I hit it on my phone, and now I'm I log into the system. So there's some welcome message here. Yeah. So we'll start with some basic things. The first thing, how do you know which shell you are using? You can use the echo $0. That will tell you that, for example, now I'm using the Bash. And if you want to know a bit more information about Bash, you can use the command winch and Bash. It will tell you which Bash you're using. This seems to be kind of useless, but it will be very useful when you're checking the Python version. So first, for example, you can check which Python. You see that there's no Python, unfortunately. I'll pull up some Python there. If we have time, we'll talk about source. Otherwise, I plan to skip it because it's too kind of complicated and I cannot explain it in 5 minutes or so. So, for example, the Python file, the Python version is installed in the Miniconda 1. And if you use the Python, so you can basically you can locate where the Python is or where the GCC is. It's pretty useful in some case if you cannot find the thing you want. And how do you know where we are? There's a command called pwd. Basically tells us now I'm in my home folder. And how do I know what kind of file I have? George kind of covered this with so you can use the ls list to list all the folders I have. Then one thing George mentioned is about the list-l. But usually, personally, I would add one more thing, H, to it. The H, I think, is human readable or something. So the only difference is that instead of presenting the file size as the pure number of bytes, now it is interpreting it into different, say, KB or megabytes or gigabytes. It's easier for me to read and
What the hell just happened?
and have an understanding of how large my file is. So this is about list. You can, so if you want to go to certain directory, you can, for example, cd into a directory. And some tricks usually I use, it's a cd space dash. If you hit enter, it actually will take you to the previous folder you are in. So it is very easy to switch between two folders. It doesn't have to be, say, they are the parent and children relationship. So you can actually cd into more things. And another command is cd with the kind of this wave symbol. It will take you back to your home folder. And again, if you play with the cd dash, it will take you to the previous folder you are in. So actually you can play with it like an infinity loop. So that's something I think I feel is pretty useful. Another thing, if you want to go to the upper folder, you can use the cd ... So it will take you to the upper folder, and if you hit it once more, it will take you back one more level up. So, another thing I want to show is the tree. Also, George mentioned a bit about it too. I think I have a pretty big folder. So if I do enter the tree, you will see that a lot of information was printed out. Then it is not readable or useful information because it's too much. So what I usually do is to redirect my output from my command line to a temporal output file. You can name it to anything, but as George said, we don't want to name, say, out1, out2, out3. So tomorrow when you enter your system, you don't know what the file is about. So you can use this symbol to redirect your output from this command to some text file. So I'm doing that. I finished how to read this text file. There are several options. The most common one is the cat. If you cat this file, again, it will just print out everything. Sometimes it is useful, but for this kind of long file, it is too much. So there's two commands. First is the more. If you use the more to read the text file, you can actually use your arrow. Use the enter to navigate line by line. I'm hitting my enter key right now. And then if you hit the space, it will move down by one screen, by another screen, by another screen. The more is an easy way to read, but the downside is that you cannot move up and down. You can only read more, but you cannot go in the other direction. So if you hit the ESC button on your keyboard, which is the upper left one, you can quit this. Oh no, you can't. Okay. So it's Control plus C. In short, it's a Control plus C to quit the more. Yeah. So another alternative way is less. If you use the less tree out.txt, then actually you can traverse with your arrows up and down. That's a pretty convenient way of reading a text file without actually open it using Vim. So, by the way, in the less, you can just hit your Q on the keyboard to quit. Q means quit. So if we want to modify some code or say some text file, you can use Vim to open it. So this is kind of the main thing I want to talk today. I want to talk about today. Well, you can modify your file on your own computer and then use scopy to copy it or upload it to the server. But sometimes it's also useful to debug in place on the server. So again, you can use the arrow keys up and down, going up, going down, going left, going right for these files. One thing is that in Vim, if you want to type any command, that is the column here, the two dots here. For example, you can say line 13. You see that so here is the 0% of the file. And if you want to, also, of course, you can also use a page up and page down to navigate the file. And if you want to modify the file, you can use you can press I on your keyboard. This I. It don't have to be capitalized. It's just the keyboard I. So you will see that here you have we're entering the insert mode. So then we can delete something. You can type something as usual, as we are using some text editors like that. And you can add lines. You can remove lines there. Once you're done with the insert, again, we can press the ESC on our keyboard to get rid of or say to exit the insert mode. Now, if I type anything, I shouldn't enter anything unless I hit the insert button. I hit the I button so that I'm in the insert mode. Again, I can quit it. There's some other useful things. One thing I feel pretty cool is how do you do the copy and paste in Vim? So you can hit the V. That is a visual. And now if you move your arrows, say going down, you see that some of the highlighted. And then let's press the button Y. Yanked. So we yanked 8 lines. And say that I want to paste the lines here. So usually a personal trick, I hit the keyboard I to insert some blank lines. And then I will quit the editing mode and then hit the keyboard P. P stands for paste. So that you can see that I have 7 more lines. And then I will remove all the blank lines. So in this way, I can clearly find where I'm pasting at. So I find this to be pretty useful in my daily usage of the Vim. And then I can press the column again and type the W, which is right, so that I'm saving my progress. And also I can type the Q to quit my editing. So one more thing I want to cover with the Vim is that you can actually use the column and slash something, for example, HTML, to actually search for something in the Vim. And if you hit the N, which is the next, it will direct you to the next matched word. So I think that's kind of some tricks I want to cover in Vim. There's one thing more I want to cover. That is the graph. So if I want to search for some keywords across the whole directory, for example, HTML, I can use a graph and dot dash, using the -R, to indicate that I'm searching the whole directory, but not just the one file. So that you can see I have a lot of things. Sorry. That's one way I found very useful in searching in the whole directory. And I think I'm kind of out of time. The last thing I think I want to, two things I want to cover. First is the set command. For example, I can replace it's very useful for replacing something across a whole file. So I want to replace all the HTML keyword in treeout.txt with hello. So I can use this command. And I will output it to a tree new.txt. So now the thing's done. I'll show you a magic kind of using Vim diff. So this is very useful in comparing two different text, two different files. You can see that the left side is treeout.txt, the right side is tree-new.txt. All the HTML is replaced to hello. This is very useful in debugging. Say you modify something, you don't know what's happening there, so you can compare it with your older version. But not that here you need to quit twice. Because we opened two different text files. And the last thing I want to cover is that last night I made a run. Yeah, I made a run WHPC.sh and it cannot run because of permission denied. I think this is also a very common issue we encounter every day in HPC system. The reason is because if you check this shell file, the permission is R and W, which is read and write, but not executable. So to fix this, you can use the chmod to change the permission from actually this is 600 to 70. I'm not going to explain the detail why it's 700, but it is 700. If you're interested in this, feel free to send me an email. I'll explain. So if we change its permission and then you list it again, you find that now we have the permission changed to X. X is execution, or executable. So now if we run it, we can run it. I think there's more I want to cover, but we don't have time. So if you're interested, you can try all the commands listed on the screen. And if you have any questions, feel free to send me an email. I'm happy to explain more. So Eric, should I hand the thing to you?
Yes. Could you answer one question though?
Yeah.
Why do you have to type that // when you're going to execute? Why can't I just type run WHPC.sh?
Good. I'm lazy. Yes, you're correct. If I just type the run or run bash space, then run WHPC, yes, I can run without any error. But to make the file system complete, usually we shouldn't run anything that is not executable. Right.
Okay.
Yeah.
All right, I will take over. Okay. All right. I assume you see my screen. And let me just go to presentation. All right, is everybody seeing it?
Yes.
Okay,
Perfect.
good. All right, so for the last section, we just want to I wanted to talk a little bit about some details of beginning to use a batch system on an HPC cluster and some of the common things you have to think about and try to things that are common problems for beginning users that we tend to answer these questions a lot. And so, for those of you who don't know, the HPC batch system is like a traffic cop. It's the when you want to run like a series or just one calculation on an HPC system, for the vast majority of systems, you're not just going to run that right on a node you're logged into. You're going to have to submit things to a batch system. And that batch system has rules, which is going to determine when jobs will run. And some of those rules, then it's going to be different for everyone's local system. So it's probably best to look into what these rules are. But in general, they tend to be of these varieties, like fair share, meaning that if you run a number of calculations in a row, you start to get an increasing penalty such that it will allow everyone that wants to run jobs to get a section of the cluster. So if you're running many days in a row, the chances that you'll run another job right away will get smaller and smaller. There are quality of service changes or settings that you can have certain groups having higher priority than others, or say maybe they put money into the system so they get higher priority access, things like that. Size of jobs can control the priority, larger jobs getting faster access than smaller jobs, or even the age of the job. If the job has been waiting a very long time, it might start to get higher and higher priority because it needs to get finished, needs to start running. And so when you're sitting there and going to run a series of calculations, some of the questions that you need to ask yourself are, what are the resources I need to run this calculation appropriately? And typically those are, how many nodes do I need? How many cores? Or if I'm using multiple nodes, how many cores per node? How much memory? How much memory do I need for this calculation? Do I need GPUs? Are there any other things that my local system makes me request, like a license for a piece of software or access to a particular file system? Now, William Mary, we don't have any license or file system requests or anything like that, but some centers do. So you should really know what you're doing on your own particular system. And so here we have a cartoon of the things that this is the picture I think of in my head. There you have two CPUs with a number of cores that also have a number of memory, slots and GPUs. And so I think if I need to run my calculation, what do I need to select out of there? And what do I also I want to do this such that I don't over ask. If my calculation uses one core and I say, hey, well, just give me the whole node, that is not useful. So I'm sorry, I was just looking at getting chat open. All right. So again, if you ask for too many resources, that's just going to slow everyone's throughput down. So it's important you do not over ask. It's I would say once a year, I will just be poking around and I'll see someone and they have like 10 nodes and the whole node for everything, and they're running one serial calculation on the first node. I mean, I tend to find that once a year. And that's really, wasteful and slows everyone down, as I've said repeatedly. All right. So again, selecting HPC resources before you want to run a batch job. So again, these questions are: first, is my code serial or parallel, which is going to indicate, the arrangement of cores I want to choose. And if it is parallel, what type of parallelism is there? How much memory do I need? Can I just rely on the default amount they're going to give me or the system will give me? Do I need a GPU? And then again, are there any other resources I need to request specific to my local center? If we look at the types of parallelism, I just want to motivate the couple of different types you commonly discuss. First of all, there's just not being parallel or serial, which uses one core. There's shared memory parallel, which is we're going to use one node only, but we're going to use some or all of the cores on that node, and all those cores are going to communicate through the memory of the system. There's distributed memory parallel, which use multiple nodes and cores, and the nodes talk to each other through, like, say, MPI calls, and the cores can as well. But if you can also split this up into be what is called a hybrid job, whereas you say, within a particular node, I'm going to use shared memory for communication, but within the nodes, between the nodes, I'll use MPI. Those are the four different flavors you'll run into, and it's best just to know what your code can do and how to run it. correctly to select those options. One thing I want to say about GPUs, everyone, it doesn't have enough, or most people don't have enough. So it's usually in demand. And so don't request GPUs if you're not going to use them. That's not good. Also, other resources, which we're not going to talk about because we don't make you request them at William Mary. And then memory use. Memory use tends to be more of a tricky one. Now, as I mentioned, batch systems tend to give you a certain amount of memory for every core you allocate. Typically, it does this. It could be different where you are. Like for instance, on some of the systems we have at William Mary, if we have a 16 core node, then if you request one core, you by default you get 1/16 of the total memory. That's just a simple way of doling out the memory. But you may be in a situation where if I run a serial job, I need more than just that default amount of memory. And sometimes you'll see something like this. Run out of memory message, that you get the infamous OOM or message, and it means that, hey, you didn't request enough memory. That job needs more than the default, and you can just simply pass that in on your batch script, which we'll talk about in a moment. Now, if you're having trouble figuring out why your job just fails, because I wanted to make a distinction between interactive and batch jobs here. Now, when we say batch job, typically that means that you're going to run asynchronously. You submit the job, it runs, completes, and you look at your data, when it's done. But there's an interactive type job where you can get a live session, and it's useful for running, tests or debugging, understanding how you use resources through your code, etc. And I recommend it if you're having trouble getting to the bottom why your job fails in the batch system. And in Slurm, this is going to be Slurm commands, but there's equivalents for all batch system flavors. We use salloc, and this salloc command, we say, hey, dash capital N1, give me one node, dash little n4, give me 4 cores, and then give me 3 hours of wall time. And when you run that command on a Slurm batch system, provided that the resources are available, you will then, as you see, the prompt turns into this KU36. So now we're on an actual node, not on the front end Kuro, which is the name of this cluster. And now we're on one of the nodes. I have 4 cores, 3 hours of wall time, and I can run a bunch of tests. I can run my calculation for 30 minutes and watch the memory usage and see, hey, what's going on there? Oh, I see. I need to request twice as much, or clearly I'm not requesting enough, or, get to the bottom of those things. But, there's caveat. There's two main downsides for interactive jobs is that, the resources have to be available. So you can often try to do an salloc job, an interactive job, and prompt will just hang, and that's because there's nothing available. And so we just recently had some questions about this on our mailing list, and I think the best solution for this is if you really need interactive job time. First of all, probably an easiest way is to contact your administrator and say, hey, is it possible for me to get this amount of time on this particular day with this many resources for some interactive jobs? Or, alternatively, you can put this command on the command line. You can put something like mail type equals begin. And so therefore, when this job starts, you get an email. So, as long as it's, starting in a reasonable amount of time and doesn't start at 3 a.m., you can jump on this node when you get the email. But keep in mind, if you have this interactive job, and so you have a session, you're logged in from home on your laptop into the cluster onto a node. If for some reason you lose that connection, that job is going to die. So that's kind of unfortunate, but it's definitely a useful thing to have in your back pocket to get to the bottom of different problems, interactive jobs. I just wanted to use this slide to talk about, the various batch directives. I have 3 batch scripts here, very simple batch scripts, just to motivate, the basic form of a batch script. These 3 batch scripts are going to use T-shell syntax because of that's the default on William Mary clusters, but you can use bash if you want. And so here, the various directives to the Slurm system have these S batch, pound S batch directives. And so the first one basically says, the first line is to indicate T shell syntax. The second line is to say, my job name is serial. And so when I query the batch system, that'll be the name of my job. And since it's serial, I ask for one core on one node. Here, I'm asking for a particular amount of memory to show you how to request 128 gigs on this system. And then here, I'm asking for 30 minutes of all time. And then the only thing the batch script does is run my calculation. And so that's a serial job. And so if you view this on the right here as a set of nodes going to the right here, you're simply just going to be using one node and one core. So we have one red bar lit up here to indicate that. Going on to shared memory parallel, this is going to use multiple cores on one node, and typically those are what are called OpenMP type jobs. Very similar to the previous script, except I asked for more than one core. And then finally, for anything beyond shared memory parallel, you're going to be requesting more than one node. So here I'm saying -N 4 nodes and 20 cores, 20 tasks per node, which essentially means cores in this context. So I'm going to get 80 cores, 20 on 4 nodes. And that would be like over here, we're going to just fill up 4 nodes, all the cores on each of them. And whether it's all MPI or hybrid does not matter for this type of batch script. And so I just wanted to motivate the idea of that you can make your batch scripts much more useful for yourself. For instance, here's a slightly more advanced batch script, just to give you some ideas of the things you can do. And so the first thing I'd like to point out in this batch script is I'm using bash, just to show you that, we can use another syntax if necessary. Bash is by far easier to program if you do a lot of scripting. And so first, what we're going to do is we're going to do a series of calculations in this batch script. This batch script is going to start and it's going to run 4 separate calculations. And the first line here, for I in backtick cat list, that's going to basically dump the file list, which I have over on the right. List consists of 4 numbers, 1, 3, 5, 6. So I'm going to say a for I in loop, and I'm going to loop over the contents of list, which is 1, 3, 5, 6. So this I will be 1 the first time it goes to the loop, 3, 5, then 6. And so in the batch script, I can say, hey, I can echo out to my output file, hey, I'm starting run 1, because that's will be the first one. And then I can print the date. If I have backtick, date, backtick, anything in backticks is evaluated before it's printed. So that will print the actual current date. And then I can make a directory based off the variable $i. I can then CD into that $, that run underscore $i. I can then run the calculation with the input and output files keyed off of the contents of this list file, echo that this run is finished with the date. I can then do other things like I can do a little bit of analysis to have in my output file, which like I'll say, hey, the energy in run $i is, and I can grep energy out of the output file $i. And so as you're running, and when the first calculation is done in your output file, you'll at least see the energy, or if, you can go and look at that after the fact, but this will have a nice output file, which will show you various things that are coming out of your calculation when it completes before it starts the next one, which could be a nice way of organizing things. And then finally, you can do other operations like, for instance, say the output file is huge. I can use the command gzip to compress that file before I move on. Then the last thing I have to do is I just have to CD up a directory, and then I start the loop over. So there's lots of creative things you can do. Lastly, one more thing that people find very, very useful is that if you're going to be doing runs where you're like looping over a series of integers or things like that, where you just want to have a particular token for each run, there's a common facility called job arrays. This is available in most batch systems, where you just tell the batch system that this batch script has, I want to run a job array. And so you say dash A or dash dash array, and I say 1 through 4. And so what this will do is it will submit a job. It'll actually submit 4 copies of this job. Each one of those jobs will have these variables set to different values depending on the context. But the most important one I'm using in here is the task ID. So the first job that runs Slurm array task ID will be a 1. The second job will be a 2. Third job will be a 3. And as you can see, you can use those 4 separate integers to key off various inputs or things like that you want to run in the separate files. And then I think I'm near my time. So I just wanted to leave with nowadays, no one really needs to be typing these things. I mean, chatbots make this very easy nowadays. You can go right to ChatGPT and say, hey, give me a Slurm batch script that's going to run this Python job, and I want it to have a job array and start at this index. And you can do all that. And then you can at least get a good close template and then just modify it yourself. I wouldn't do any of these from scratch anymore. All right, well, that's all I wanted to get at. And I wanted to give people the opportunity to ask questions. All right.
Can I just thank everybody? It's been fantastic. Thank you, the 3 speakers.
Oh, I also did not know about, there's a comment about not knowing about Vim diff. I also did not know about that, but I don't use Vim, so that's why.
Vim diff is awesome. I thank you, Lishan, because I've used diff my whole life, but
Yeah.
we know how diff is clunky, right? Because you got to export the difference into an extra file and then
Yeah.
view that file. But this is fantastic. Thank you, Lishan.
Oh, that's a good question. How do we extend our time or end jobs in the interactive session? Well, if you have requested only 30 minutes or a certain amount of time, I don't think you can extend your wall time because you're already in the queue. I think you have to ask an administrator to do that. I could be wrong. That could just be our rules. To end it, you literally just exit from the session. You can type exit, Control D, anything like that. It's just like exiting any normal shell you would do.
And when you do that, your unused time is released. So,
Yeah. Yeah, you can go in and spend 2 minutes, and then once you exit, you give all that time back, like George said. All right. Well, I hope this was useful for some people, just at least see the flavor of it. These slides will be on the Virginia Women in HPC site if people want to look some more. And if you think there's anything that you want to ask questions about, I would reach out to us directly. All right. Well, thank you everyone for coming.